From Imperial College London, welcome to this special lecture vodcast.
And it's great to be here. In fact, last time I was in this room, I was judging a science writing competition. I would beg anyone from the age of 15 to 28, do enter our Telegraph Bayer science writer competition. And it's actually been amazingly 10 years since I was working on Can Reindeer Fly? Oh, now I'm trying to use my widget here. There we are. And or the physics of Christmas in America. And what I was trying to do was to go over some of the things in the seasonal celebrations, but looking at them from a strange perspective, that of science. And in fact, when I tried to get publishers interested in the book, there was almost zero interest when I started out, and now it's published in lots and lots of countries. But let's just look at this scene for a moment. Now, I want you just to imagine what it must have felt like during winter, tens of thousands of years ago in northern Europe, when the hours of daylight were getting shorter and shorter. You could see the leaves falling off the trees. It was snowing, it was getting colder and colder, things were damp and decaying. There's little food. And if you'd been around one of the early humans there was a big fear of starvation, a very high likelihood of starvation. In fact, one reason that we've got a propensity to be fat today is that our ancestors who survived back then probably had genetic machinery to efficiently lay down stores of fat. And you've got to remember that if you look at life on the planet, pretty much everything except for little bugs, strange bugs on the sea bed, depends on sunlight. We've got a sunlight-driven living economy. And if you remove that sunlight, you've got darkness, you've got terror, you've got death. Now that's the kind of primal spirit of Christmas. So the hours of daylight are getting shorter and shorter until they reach the minimum around the winter solstice of December the 21st, which is pretty close to Christmas Day. Now I want you to imagine there's a bunch of starving Neanderthals. It's 40,000 years ago. They're sitting in a cold, dark cave, and they're gazing onto this scene. And one of them, they've all got ginger hair. Let's say he's called Ugg. He's of a philosophical disposition. I say, fellow tribesmen, now remember, new evidence suggests that Neanderthals can talk. They had a FOXP gene, rather like we do. They had a hyoid or a tongue bone. They had bigger brains than we did. So I think it's reasonable. I mean, we must be able to have an upper-class Neanderthal. So there's Ugg, and he's saying, now what if the sun disappears altogether? Now I'm going to catch my death, and we're all going to freeze and die. Now, they got worried about this. Primitive man, primitive woman were frightened that that sun was never going to come back. And they needed some kind of ritual. They thought, what about if we just do something just to guarantee that the sun comes back? Now, the great news is that whatever they decided to do was going to work. You sacrifice a chicken, sun comes back. You hit your fellow Neanderthal on the head, sun comes back. That's good. You chop his head off, still works. Fantastic. Run around, waving your arms, the sun's going to come back. Very reinforcing activity. But in fact, early man chose certain symbols for very good reason. Now, one of them was evergreens. You can imagine a primitive mind in a deciduous world. An evergreen suggested permanence. It suggested a kind of magical ability to flourish without help from the sun. The same goes for things with berries, like holly and mistletoe. So it's no surprise that this is the season of holly and ivy. Another symbol is a candle. Flames are universal for these kinds of celebrations. Norsemen used to burn Yule logs through the night. So you can see the very primal origins of our Christmas. The celebrations go back way before the event that supposedly got Christmas going, the birth of Jesus. And early Christians very cleverly cannibalized these celebrations to make them their own. Now, 2 millennia after it was first seen by the wise men, astronomers are still arguing about what was the Star of Bethlehem. Now, if you look at the Bible, you find that the star wasn't very brilliant. Certainly wasn't the brilliant object that you see on Christmas cards. King Herod and all his chief priests and scribes missed it. St. Matthew doesn't use the adjective bright to describe it in his gospel. And it's only in the very early, less reliable Christian literature that you find a dazzling star. Now, we could easily identify the star if we knew precisely when Jesus was born. Then we could just use a computer program, you can get them on the web, wind back the clock, you can extrapolate from what we can see in the heavens today to what the wise men must have seen on that historic night. But there's a big problem. We don't know when Jesus was born exactly. And he wasn't born the obvious time because of a guy called Dionysius, a monk. And he made a complete mess of the AD, the Anno Domini sequence that we use today. He overlooked 4 years of the rule of Augustus, suggesting that Jesus was probably born around 4 BC. He didn't have the concept of zero, so the first year in his calendar was AD 1, and that's why the real millennium celebrations, for all those arguments a few years ago, were on 31st of December 2000. Now, you can look through the Bible, you can get various clues, and you can figure out that Jesus was probably born sometime between 4 BC and 7 BC. But was he born around Christmas? Well, if you believe Luke, who was talking about shepherds and their flocks, then the answer has to be no, because the lambing season's in the spring, or he might have been referring to the autumn when flocks were being collected. So now we can come up with a few potential candidates for the Bethlehem star. So one idea is that it was a comet, or a broom star, so called because the comet's tail appeared to be sweeping the sky. Now, there was one described in 5 BC by Chinese astronomers, and it was actually recorded in the official history of the Han Dynasty. Now, if you talk to Colin Humphreys at Cambridge University, he thought that the comet could seem to hang over a spot, particularly if it was low in the sky and its tail was oriented vertically. And he thinks this fits Matthew's account of lo, the star which they'd seen in the east went before them till it came and stood over where the young child was. There has actually, though, been a lot of debate about this. Now, critics point out that Ptolemy, the 2nd century astrologer from Alexandria, associated comets with misfortune, and maybe had good reason to do that because, you know, we've got plenty of evidence of these sorts of impact events wiping out huge chunks of life on Earth. So another idea is that maybe the wise men saw a supernova, an exploding star. But there's a problem with this one as well, because if it was close enough to Earth to be seen, you'd expect to see a splash of radio and X-rays today, and we can't actually detect that today, so we can rule that one out. Good old Patrick Moore claims the star was 2 meteors, or shooting stars, and they rose in the east, crossed the sky in a westward direction, and they left a trail. But I think we're missing something here. I think the objective perspective of an astronomer is inadequate for the search for the Bethlehem star. I mean, not least because real stars just don't stop over Bethlehem. What we really have to do is we have to understand who were the wise men. They were the people interpreting the heavens. Before the 17th century, there wasn't the sharp division between astronomy and astrology. And we now know astrologers talk rubbish all the time, and astronomers talk rubbish only some of the time. Now, okay, they both like the night sky, but you can understand why astrology was so powerful. Early on, if you had a knowledge of the heavens, you had an ability to tell the future in a very limited sense. You could tell, it could guide you through the seasons, it can tell you when to harvest your crops, it could tell you when to move herds. It could also help you predict something like a solar eclipse. Or imagine the power. If you said to someone, the sun's going to be darkened for a few moments tomorrow, and it happens, they would be, to put it mildly, impressed. It could predict the flooding of rivers like the Nile. So you can see why astrology took root. People thought, if you can predict these things, surely you can predict something deeper about human nature. And astrology was practiced through the Roman world and in the Near East that included Judea. So the Magi, with their detailed knowledge of the night skies, they wouldn't have been impressed by a routine event like a shooting star. They're actually depicted as a religious group skilled in the observation of the heavens. They probably came from Babylon, because in the 4th century BC, that was a center of astronomy in the known world. They were probably from the Babylonian royal court in Mesopotamia. There was also a Jewish colony there. So the Jewish prophecies of a Saviour King, the Messiah, might well have been well known to them. So what sort of things were they looking for? In the astrology of the day, Jupiter was the king planet. They were also interested in retrograde motions. This is a consequence of the relative position of the planets around the sun, when, from the perspective of the Earth, it looks like the planet makes a loop against the stars. They were interested in conjunctions, when heavenly objects came together, or occultations, when one object in the sky hides another. They were looking at patterns in the sky. They weren't looking at astronomical events like supernova, but patterns of dots that meant something to them. There's lots of theories out there. One that I found particularly striking was Mike Molnar of Rutgers. He's put forward a Star of Bethlehem candidate that he thinks took place on the 17th of April in 6 BC, and this was a double occultation of Jupiter by the moon. Now, he notes that astrological signs appeared on ancient coinage from Antioch, which is the capital of the Roman province of Syria. On one side of the coin, you had Jupiter, the king. On the other side, you had Aries, the ram, which is linked to Judea, and that gazed back at a star. And he found 2 bullseye conjunctions where the moon's disk obscured Jupiter. There were 2 that took place in Aries and thus in Judea. He had one on the 20th of March 6 BC and one on the 17th of April 6 BC. And it was the latter one that got him quite excited, because that's when Jupiter was precisely in the east, and that seems to be the terminology that Matthew uses to describe the Magi's star. And the heavens, therefore, on the 17th of April 6 BC, produced these amazing astrological portents pointing to the birth of a king of Judea. So we've solved the mystery of the star. Well, maybe not, because David Hughes of Sheffield University says that occultations are far too common to impress these wise men. He liked the idea of a triple conjunction between Jupiter, Saturn, and the constellation of Pisces. That was in 7 BC. You had the regal aspect from Jupiter. Saturn stood for the principle of justice and the land of Palestine. Pisces was a sign of the zodiac that represented Israel. And so you've got the whole lot. You had divinity, you have kingship, you've got righteousness involving Jewish people in the promised land. And that's why the wise men went to Jerusalem. But the bottom line for me is that the Bible is way too vague to ever sort out the Star of Bethlehem. And I guarantee, if not this Christmas, next Christmas, we'll have yet another theory coming along. Then we've got the birth of Jesus himself. Baby Jesus presents a few problems for modern biology. Now, I'm going to leave aside a theological issue about when is a miracle really a miracle. But this is something that actually a professor of genetics, Sam Berry, has had a look at. And he's a man with strong religious beliefs. And he wanted an explanation for the miracle. Now, as I say, let's leave that aside. Do you need to explain miracles? Discuss. I suspect you don't. But there's a problem, because the genetic recipe for Jesus must have come from Mary. And she's a girl and he's a boy. That's problematic. There's something called parthenogenesis, which is like a form of cloning, where an egg spontaneously starts developing, but then you always end up with a girl. So for Mary to give birth to a boy by parthenogenesis, she'd also have to have a Y chromosome. That's what distinguishes boys from girls. And that does create a really big headache. Sam Berry has come up with several biologically conceivable, dimly conceivable mechanisms. And what it basically involves is that either Jesus was genetically female but looked male, or Mary was genetically male but functionally female. You're getting a bit of a headache now. I think I'll rapidly move on. It's just all a bit too miraculous to take seriously. Now, strangely enough, the highest organism in which parthenogenesis is possible to make a male is the good old turkey. Now, the turkey began its invasion of Europe in 1519, when the birds were brought back from the New World in Spain. By 1851, the invasion was really doing well. It replaced the swan on Queen Victoria's dinner table. And turkey's mean a lot to me. Now, I've got to confess, I find the taste of turkey boring, and I'd rather not eat turkey, but my wife insists on it. But it means a lot to me because my very first Science of Christmas story was about 21 years ago, and it was on how to cook a turkey, and there was even an equation of how to do it, and it assumed a homogeneous spherical turkey. And that sort of got me interested in this weird overlap between science and Christmas. Now, what about the future of the roast turkey? Now, I've actually consulted Peter Barham and Len Fisher of Bristol University. I wanted them to push back the frontiers of culinary science and to find the perfect way to cook the turkey. Now, this bird is annoying to cook for various reasons. It's loaded, or its wings and its legs are loaded with connective tissue. These are the tough white sheets and strands, can't get the words out here, that join the muscles to the bones. Then you've got the delicate breast meat, which has much less connective tissue, much more tender. So you've got to come up with a cooking method that's going to, really zap the tougher bits of the bird and yet be tender with the breast meat and so on. So we need a clever way to apply heat very sort of precisely to different bits of the bird. So I said to these guys, look, come on, how are we going to do it? And this is part of their approach. The Keck telescopes in Hawaii. These are huge telescopes. Each is 8 stories tall, weighs 300 tons, and yet operates with nanometer precision. Now, at the heart of each one, we've got a revolutionary primary mirror, 10 meters in diameter. We've got 36 hexagonal segments. They all work in concert together as a single piece of reflective glass. And it's a very clever system called adaptive optics to take account of how stars seem to twinkle because of fluctuations in the atmosphere. And with this clever mirror, we can actually deal with that. But of course, Len Fisher and Peter Barham realized that maybe we could use this exotic array of mirrors with a laser system to focus laser beams down different intensities on a bird slowly turning on a spit at the heart of the Keck telescope. Of course, you dot the bird with thermocouples. You could monitor with incredible precision each temperature. You could also link it to a computer, a neural network program. Now, neural nets mimic the action of the human brain. They're full of interconnected processes like the neurons in our brains, and unlike all politicians I can think of, they can actually learn from their mistakes. So you can imagine the computer will control the process, turning the bird, fluctuate the laser beams, and so on until the food is perfectly cooked. And all it will cost is a few £100 million. So there we are. Eat your heart out, Heston Blumenthal. Okay, now what about these beautiful crystals? Now, many believe that science takes the wonder out of the world by analyzing it to death. And I think that snow, for me, it's, we've all encountered snow, we've handled it, and it actually shows the reverse is true. I think the more we know about water, the more mysterious and exotic it becomes. This really is one of the most extraordinary substances on the planet. Now, we all know the structure of water. It's got 1 oxygen atom, 2 relatively tiny hydrogen atoms. It's in this V shape. But it's a really strange liquid at room temperature. You have substances made of similarly shaped, similarly sized molecules such as methane. They're gases. In fact, the boiling point and the melting point and the heat conducting abilities of water are much higher than those of any comparable substance. And most substances shrink when you cool them, but ice takes up more space. And this is pretty bad news if you're on the Titanic, of course. But for anything that swims and paddles and wallows, the good news is that when a lake freezes, you get an insulating layer of ice on top. And it actually protects the waters underneath, so they become they still remain liquid. So water also has very important solvent properties. So you put all this together, and that's why water is central for the search for alien life, whether it's on Mars or whether it's on exoplanets, these alien planets orbiting other stars. And what's extraordinary is that there's at least, the last time I looked anyway, 13 different types of ice. There's probably more, since they do seem to be discovered routinely, and it's all to do with how these water molecules link up. Now, the oxygen in water is really greedy for electrons, slurping the electrons off these hydrogens And meanwhile, you've got kind of rabbit ears of electrons sticking up the other side of the water molecule. So you get them sticking to the hydrogens here. Partly they've had the electrons slurped off, a bit positive, and they stick together to form these huge networks. And that's why they linked it up to make a liquid rather than move independently as a gas. And also in ice, these hydrogen bonds, as they're called, hold each water molecule apart at bond's length. And that's why we should blame hydrogen bonds for the loss of the Titanic, because they make it less dense. There's also other mysteries, because below freezing, these molecules link together in larger networks, and you can see this six-fold symmetry here. That's where we get the lovely six-fold hexagonal symmetry of snowflakes from. Now, what's rather amazing is that using a method called molecular beams, you can actually stick together water molecules one at a time. So you can look at the smallest ice cubes possible. And in fact, they've been made by a guy called Tim Zwier at Purdue University. 8 water molecules. You can actually study them by seeing the way that they absorb infrared light. And what you find is that if you stick 8 water molecules together, you actually get 2 different forms. If you look at them closely, you'll see this guy here is not quite the same. So if anyone asks you the question, are 2 snowflakes ever exactly the same? Just remember, if you have 8 water molecules stuck together in the smallest possible ice cubes, you can have 2 different arrangements. So the answer is no, there's no way. So much for the details of ice crystals. Now, of course, what we really want is a white Christmas. How are we going to guarantee a white Christmas this Christmas? Well, one thing you can do is just head for the snow line. So if you go to higher polar latitudes, that's at sea level. In northern Scandinavia, it's about 1,200 meters. In the Alps, it's about 2,500 meters. And in the Himalayas, it's about 4,500 meters. But surely we don't have to travel. We don't have to be slaves to geography and season. Well, there are a few ways to get past this. We could use a water cannon and have that blasting away. But, you know, let's say if we wanted it to snow in London, I mean, you can't imagine arrays of water cannons blasting away all over the place. So what can we do to guarantee that we got a Christmas like this, and on Christmas Day? Well, I rang up the Met Office a few years ago and said to them, look, we've got to have snow this Christmas. What are we going to do? And they pointed out that what we're going to do is reproduce the effect that usually triggers snow in the first place. And what you get is usually air coming in from the continent, chills down the country, and then a warm mass of moist air moves in from the Atlantic. Precipitation, and that's the pretentious Met man's way of saying snow. Yippee, we're in business. So how do we guarantee that on Christmas Day? Because it only snows about once every dozen years on Christmas Day in London. Here's the answer. Now, anyone who's Irish and of a weak disposition should probably leave the lecture theatre now. What you've got to do is just to make Ireland more mountainous, okay? So just build lots of mountains up and down Ireland, okay? That will act as a block in the Atlantic, stop that warm, moist air from coming in. That will let the chilly breeze from Europe chill down the whole of the UK, hopefully London too. And then on Christmas Eve, this is the easy bit, you just demolish the whole thing all over again. And the end result is, voila, you get snow. Now, funnily enough, when the Met man explained this to me, he said it could be a tad impractical. So there we are. Now, what about Santa? Who is Santa Claus? Anyone know? Well, the great thing is, like any big issue, there's lots of scientific theories out there. If you go back before the 1930s, you'll find that Santa appears in lots of different forms in popular culture. He was a green elf. He was a somber St. Nicholas. He was a gaunt figure clad in skins and a sort of opportunity for animal rights protesters. But all that changed in 1931. Now, I'm giving you the official Coca-Cola view of Christmas now. That's when Coca-Cola commissioned a young Swedish artist called Haddon Sundblom to give Santa a bit of a makeover. And he produced a new Santa image each year. We had Santa, he had his ample red coat, it was trimmed in white, thick leather belt, Perhaps anticipating modern concerns about smoking, he got rid of his pipe. He had his bottle of Coke, of course. Then he posed with children, with reindeer, sacks of toys. He never let go of that bloody fizzy drink, though. He'd be staring at it. He'd be, grasping it, waving it around, ready for that pause that refreshes. But I don't think I buy the Coca-Cola view of history, and I'm going to give you a couple of interesting alternative Santa perspectives. So where do you think Santa Claus is right now? Sitting in front of blazing embers with a glass of sherry in a cozy wooden house in the Arctic. You can hear the snow gently sort of pattering down outside. Maybe he's feeding those reindeer, of course, or perhaps he's making a few last-minute adjustments to his route across the North Pole. Well, I think you should think again, because this is probably where Santa started out. Because there's evidence to suggest that Santa's grotto lies among Mediterranean olive groves on Gamilla, which is a little island off Turkey. Now, if you talk to the locals there, they'll tell you that 12th century Venetian seafarers called it the island of San Nicolo. And on a church door near the anchorage on the island, you can see a painting of St. Nicholas himself. He was born in AD 245. He probably died something like 343 AD. And he became very famous. And there were lots of legends about him doing things like dropping gold pieces down the chimneys of poor unmarried maidens for a dowry. So maybe that's where the idea of Christmas stockings and Santa's affinity for fireplaces came from. And you've got old Byzantine portraits of him, showing him with a long white beard. And then when the Reformed Church spread through Europe, he became linked with Christmas, since his saint's day is the 6th of December. And though it's only half a mile long, this island has got at least 5 churches decorated with frescoes and mosaics. And it was obviously a very important religious site dedicated to St. Nicholas. It's got a huge Byzantine ecclesiastical complex with a 300-metre barrel-vaulted processional way. And for some reason, after 650, we're not really quite sure, the veneration came to an end and the community was abandoned. And the site lay forgotten and forlorn. But it does raise the interesting question that when you send your letter to Santa, which I'm sure you're all going to do, should you address it to Gamilla rather than the North Pole? And also, should we reform our vision of Santa and have him doing this? Now, of course, again, this isn't the only Santa theory out there. Lots of great Santa theories. Look at this chap here. Now, the origins of this Santa are in a crypt in Bari in southern Italy. St. Nicholas's remains were exhumed from there in 1953, and the Vatican granted Luigi Martino permission to examine the bones of St. Nicholas. Half a century later, Caroline Wilkinson, who's an anthropologist at Manchester University, used the X-rays of the remains of St. Nicholas and measurements to create a simulated clay model of the saint's head. And then they produced the face using a virtual face reconstruction method at the Image Foundry Studios. And they got a basic image of what St. Nicholas would have looked like. Then they studied religious leaders on Orthodox icons. They figured out he must have had a nice trimmed white beard. That was the fashion, not that big billowy one that old Haddon Sundblom liked. And what you end up with is a bit of a far cry from the chubby, rosy-cheeked, blue-eyed, jolly old white man. You've got a sort of short, tough-looking guy, aged about 60, masculine square face, broken nose. Look at him now, what would he be doing? Rugby player, maybe, former rugby player, bit of a thug. Perhaps he could be doing crowd control outside the Christmas sales. But for me, by far my favourite Santa explanation, the robes, the reindeer, all the trappings of Christmas, they all depend on what's probably the most important toadstool in history. And here it is, Fly agaric. Now, Amanita muscaria was the recreational and ritualistic drug of choice in Northern Europe before vodka was imported from the East. It's poisonous, so don't eat this toadstool. But in Lap societies, ancient Lap societies, the village holy man or shaman knew how to prepare it. They knew how to remove the potent toxins, so it was sort of safe enough to take. I must admit, I would never take it. The hallucinogenic properties are due to something called ibotenic acid and muscimol. You get ibotenic acid in fresh toadstools, but when you dry it, it turns into muscimol, which is 10 times more potent. And shaman, with good reason, took their mushrooms dried. So you can see, you can get a strange picture of where Christmas might have come from. You've got a mushroom-induced trance. You can imagine the shaman was consulted during times of need. There could have been sickness in a village, or people were desperate for food or something like that. So he wanted to go to the spirit world and see what to do. So he'd reach for his toadstool. He'd prepare it carefully. He'd start to twitch and he'd start to sweat. He'd feel that his body would be left in, he would leave his body in the form of an animal. That might be where the flying reindeer came from. You've got the idea of the gift of healing, rather than something from Marks and Spencer's as we have today. You've got Santa's jolly ho ho ho, which is the euphoric laugh of someone who's been indulging in psychedelic treats. You've got the flying reindeer as well. You've got the colour scheme of his outfit, which reflect the toadstool. And his fondness for popping down chimneys could be because the dwellings of the shaman in Lap societies were yurts. And it turns out the door of the yurt is the same as the chimney. So you've got him coming down the chimney, in effect, with the gift of knowledge. And you can still see, particularly in Central Europe, many chimney sweeps carry a logo, the toadstool logo. You use it as a Christmas decoration, and so on. You've got the red and white, you've got the hysterical ho-ho-hos, the presents, the chimney, the lot. So for me, I go for the fungus explanation. And here's me and Raj Persaud grilling Santa about his long history of drug experimentation. Now, what about Rudolph? What about that red nose? Could it be the cold? That's a bit of a boring theory, so I think we'll forget about that one. Could it be all that sherry left out next to the chimneys? Well, maybe. You know, it seems a bit depressing, a bit of a slur on Rudolph, if you ask me. Could it be the air friction heating his nose at high speed? Well, maybe, I suppose. In fact, there was quite a good answer given in the journal Parasitology Today a few years ago by Odd Halverson, that really is his name, Odd, at Tromsø University. And he reckoned that it was probably due to some sort of infection. It turns out that reindeer have got a fantastically good air conditioning system in their noses. You've got that cold air, they've got to warm it up before it gets in the body. Lots of folds and little closed bits for bugs to hang out in. And he concluded that Rudolph is suffering from a chronic parasitic infection of his respiratory system. So there we are. Now the only problem, though, with the image of Rudolph that bothered Odd was that he has antlers. Now, it turns out that a lot of ritual combat and fighting takes place between reindeer at this time of year, and they lose their antlers, also due to the action of sex hormones. Now, in fact, the Sami people, the reindeer people in the Lap societies, actually stopped this by castrating males. So the next time you see a card with Rudolph with his magnificent headgear, you're either looking at Rosie, the red-nosed reindeer, or a castrated male. Okay, here's Santa delivering his presents. Now, a few years ago, Spy magazine published a rather scandalous article, I think, that has proliferated all over the internet. And they were trying to analyze what Santa would have to do to deliver all the presents on Christmas Eve. And they reckoned that he'd need 214,000 reindeer. And with all the presents, he'd encounter huge air resistance. He'd heat up so much that it would be a bit like a spacecraft re-entering the Earth's atmosphere. And for poor old Santa, reindeer and presents, they would burst into flames almost instantaneously. I can't even bear to read this stuff out, it's so upsetting. Creating deafening sonic booms in their wake. And they would be subjected to forces 17,500 times greater than gravity. And they concluded if Santa Claus ever did deliver presents on Christmas Eve, he's dead now. Now, it's a bit of a gloomy. Now, I'd just like to, before you get too upset, hang on, guys, it's okay. Because each and every Christmas, NORAD, which was set up by the US military to track ICBMs from the former Soviet Union, actually tracks Rudolph, okay, as he makes his trip around the planet. It has to be true. So how on earth does he do it? Okay, sleighs, well, a bit slow. Maybe Santa ski, still a little bit slow, I think, to do the whole lot Christmas Eve. Now, this is the luxury option, but I still reckon he's going to have problems, even in this lovely stretched limo. Skidoos, no good on suburban roads. Here's a nice rocket sleigh. Now, that's a bit more like it, but could reindeer fly? Now, it turns out that if you study fruit flies, which are the favourite insects of experimentation for scientists, there are things called homeotic genes. And when you mutate them and fiddle around with them, you can do all sorts of peculiar things. So you can have flies with legs sticking out their heads, you can have shriveled wings, you can have curly wings, and you can have extra wings as well. Now, if you talk to Matthew Freeman at the legendary laboratory for molecular biology in Cambridge, he'll tell you that work by Cliff Tabin at Harvard Medical School has shown that genes that specify limbs in flies are just the same in mammals and work in a very similar way. So perhaps, with a bit of genetic wizardry, we could get Rudolph to grow some stabilizers or even some wings. Now, you're probably thinking, this is very far-fetched. But I'd just like to say, we need confirmation. Scientists always need confirmation. We've got it in Greek mythology. Pegasus, the winged horse, it's been done already. Maybe it could have been done again. But there's, of course, other explanations there. And one thing is we might have neglected one of the most important features of Rudolph, namely this magnificent headgear. We talked to Ian Stewart at Warwick University. He thinks that what we naively called antlers are actually fractal vortex shedding devices. Oh yes. He points out that at supersonic speeds, Concorde generated lift by shedding big helical-shaped vortices from the leading edge of each wing. Now, the reindeer travel at much higher speeds, of course. They play the same trick with the prongs of their antlers. These spin off all sorts of vortices to generate tons of lift. And Stewart makes, I think, a very good point about reindeer and their antlers. He says, look, if you look at a penguin, they look rather inelegant when they walk on land, but when you see them swim underwater, they're beautiful swimmers. So maybe, you know, we don't give reindeer their due. It's only when they hit really high speeds that the antlers kick in, they get tons of lift and all the rest of it. But I've got to confess, I do think flying reindeer, still some big challenges. If you do the maths, let's say there's about 2 billion children in the world, 2.5 children per house. That means Santa Claus is going to make 842 million stops on Christmas Eve. If you assume the homes are spread evenly across the planet, you've got distance between each household. I'm sure you're working this out, guys. I'll test you on it later. 0.26 miles. So you can get the average spacing between households, add it all together. That means he's got to travel 221 million miles. And that means he's got about 2/10,000ths of a second to get between each household, which means he travels at an average speed of 1,279 miles per second, or Mach 6,395. That's quite a big challenge, actually. So what are we going to do about that? Larry Silverberg at North Carolina State University has pointed out that maybe Santa exploits warp drive technology, and because I'm running out of time, I'm going to zip through this, except just to say that you might think that warp drives are science fiction, but in fact the British Interplanetary Society was discussing the ideas of Miguel Alcubierre in London only a few days ago, so that's one possibility. Good old Ian Stewart has come up again with an idea to use exotic materials to cut and paste bits of the universe together using space-time shortcuts we call wormholes. So you can imagine you've got one end of the wormhole in Gamilla, of course. He's got his presents, he zips into one portal, passes through the wormhole, emerges from another in your front room, dumps the presents, zips back into the wormhole. You can tinker a bit with time travel as well. And of course, again, because this is a leading edge area of science where lots of the finest minds on the planet are thinking about this problem, there are alternative explanations. Here's one alternative: quantum teleportation. Now, teleportation is a sort of real-world version of Star Trek's transporter. It was developed by Anton Zeilinger at the University of Innsbruck. He didn't teleport whole particles or photons, but just their quantum states. But it did suggest that maybe we could teleport Santa around. Now, in fact, when Star Trek used transporter technology, it was to deal with a very straightforward problem, that Gene Roddenberry didn't have the budget to be able to make little model spacecraft landing on planets. And this is a really cheap way to show Captain Kirk et al. Getting down on the planet. But the nice thing is that actually it is at least theoretically possible that we might be able to teleport things today. And if you talk to Samuel Braunstein, who's a British quantum boffin, if you resolved your body down to a resolution of about 1 millimeter, you need about 10 gigabytes of data. If you wanted to get all the information from the body to teleport it, you'd need something like 10 to the power of 32. That's a pretty huge number. It sounds a bit unlikely, but I did consult one of the great gods of quantum teleportation, Charles Bennett of IBM, who said it's still theoretically possible. So it could be that Santa's teleporting down into your living room and so on. So I think there's a lot of evidence here that Santa's really doing it. Forget all these myths about parents depositing presents and girlfriends and things. And this is my image of Santa, just to conclude. And I want to also point out a very much neglected clue here. You see this growth here? We call it a beard. Now, this is very important indeed. Many famous bearded thinkers, Hippocrates, Pasteur, Freud, Darwin, and it also turns out the new government chief scientist, John Beddington, is a beardy too. This is a very important fact. Sarah Carter at the Centre for Applied Science and Pharmacy in University of London studied 1,800 university males and found that senior academics are more likely to be shaggy. And in fact, the bigger your academic credentials, the bigger your beard and the more facial growth you get. Now, you may doubt this, but it's in the Pharmaceutical Journal. You can look up, I can give you the reference afterwards, okay? So, the fact that Santa's got a beard means he's a very, very smart guy. So, we've got to ask ourselves, finally, what is it about the facial hair that makes him smart? Now, it could be linked with testosterone. That's linked with aggression, a drive, a jutting jaw, high reproductive success. Perhaps that's something to do with Santa's drive. Of course, it could be that it's just a side effect of being a very busy academic. You haven't got the time to shave. Or maybe there's peer pressure, psychological issues coming in here. They've got to keep up with their academic peers. Big beard, take me more seriously. There are a lot of theories out there. I can go on all night about beards, actually. Just don't get me going. Now, have you noticed when people have beards, they touch them a lot? Seems to aid higher thought processes. You know, he's got his warp drive slave to worry about, things like that. And I'd also like to make a point that people accuse the scientific establishment of chronic institutional sexism. Well, it's rubbish. I'd just like to point out women don't have beards, and that's the explanation. And it also suggests, Sir Richard, if you want to get on in life and be even more successful, a bit of facial fuzz wouldn't go amiss. So there you've got it. You've got the origins of Christmas, you've got the star, the virgin birth, the turkey, Santa Claus, and that wonderful beard. So, Merry Christmas. Yeah, sure.
You've been listening to a special lecture vodcast from Imperial College London.